All right, so first off, let's talk about that data analysis, or data analysis. So different kinds of graphs are tested on the GRE, and here we have the various types kind of in snapshot form. So you'll have bar graphs, and you'll note this one has all sorts of stripes on it. There's more information contained in a single bar here than on some bar graphs. You know, according to different colors. You may have tables, which are simply, you know, information organized into rows and columns. You may have circle graphs, or pie charts, as many people call them, because it looks like a very unfairly divided piece of pie. And we may also have, really you may also have line graphs, and this one only has 2 lines, but it could have a whole bunch. Let's talk about these in depth and kind of how you have to approach them and what you have to look for. So, there we go. First off, the bar graphs, so named because there are bars in them. You probably figured that out. So they could be simple bar graphs, like this one. It's monochrome, well, the picture itself has 2 colors, but the bars themselves are a single color, and so one single bar just represents a continuous whole. And then you may also have ones like this, though, where the bars themselves are subdivided into multiple other types of information. Each of these bars is, in a way, its own kind of pie chart, which shows proportionally how different elements make up that whole. Which then it would be as if you had lined up 5 pie charts next to each other and could compare them. But even so, this still does a better job of giving you a sense of how big the wholes are relative to each other. You know, so lining up pie charts together wouldn't necessarily give you the sense of this for these 5 countries. So, bar graphs can be relatively simple or relatively complex. And again, it can be given as in conjunction with other types of information, so you do need to be careful and look for what exactly these things are telling you. So on these bar graphs, first off, the first things that should jump out at you and that you should make sure you appreciate are what the biggest ones are and what the smallest ones are. So that's probably these 2 here. And then the biggest one is this guy, and the smallest one is this guy. Maybe that sounds obvious, but a lot of questions, a lot of wrong answer choices will often hinge on misidentification of those things. And then relate the bars to each other, try to figure out what these things are. Note that these are broken down into 2 different categories. Note that these are, you know, countries, and that their stripes do not all have the same proportions of the total bar. Right, and so the most important thing then to look at here is then, you know, as always, actually this is true of most different types, you need to make sure you pay attention to the axes, you know, so this is 90, 0 to 90, but what is it? Oh, it's percent. You actually have to read the title. Maybe that sounds silly, but sometimes information, in this case, the only way that you know that this is 90% as opposed to 90,000 or 90 trillion or 90 degrees, the only way you know that this 90 is a percent is from the actual title of the graph. So make sure you read that, or things could go badly for you. So titles, any legends, note this line here dividing this graph into 2 parts. There's no such one over here. Note that these different sources of money, of income, basically, or of gross domestic product, note that they do appear in the same order in each bar, but they don't necessarily have the same proportion. Here we get countries, here we have kind of departments or areas of expertise, or by type, really. That's why we look at the title. And again, here we have numbers. The scale, or not the scale, the legend, it doesn't tell us what this is, 1500, 2000, 2500. It doesn't tell us what this is out of, or what this is of, until we actually read the original thing, and that's actually number of engineers. So bar graphs, I mean, I don't think this is going to suddenly reveal what bar graphs are like in a way that you've never thought of before. What I'm trying to impress upon you is that the information can be very densely put in there, and that it's very important to pay attention to every element of the graph. All right, so circle graphs or pie charts, these show proportions basically of all things that make up a whole. as bar graphs may or may not do, as we saw previously. So the two things that you need to look at, first off, are what's on the pie slices. You definitely need to pay attention to what the biggest one is. Oh, I even misidentified the biggest one. It's actually this one here, 29.4% versus 27.8%. I just looked at that one and thought it was bigger. Don't do what I just did on the test. And then the smallest one clearly is here, corporations, 2.1%. On the graph, then, you also need to make sure that you notice the other things like the title, income and expenditures. Here, clearly this graph is income. It suggests that there may have been another paired expenditures graph that was maybe also was a pie chart. We have the total that it's out of. That's one very, very, very important thing to look for on pie charts. Let me just re-emphasize this. The total amount is something you should identify whenever it is given, whether it is given on that pie chart or elsewhere in the data that you're given to look at. Because this 70 million, you may be asked, for example, to compare actual amounts. You know, what was the actual amount spent on local municipalities? Well, if you didn't notice that the 70 million was here, there's no way that you would be able to get a number. I mean, I guess you could guess lucky, but you shouldn't count on that on the test. 14.3% of what? That 70 million is the only way of finding out. Okay, so, and again, the title may tell you other information, especially note years. You may be given several years worth of information in one question or series of questions. So, I guess the big takeaway that I want you to have from this, read the stuff aside from the pie chart, especially the total amount. So line graphs can do some of the same sorts of things as bar graphs, except they also track trends, often over time. So note here we have our, whoops, didn't have the pen thing on, there we go. Note here we have years from left to right. This time there is a legend on the key telling us what the axes represent. These are expenditures, these are years. 200 what? Oh, up here in the title, billions of dollars. We're given some date ranges, and then we have some trends here, generally upward trends from the look of it. So just to summarize, definitely, so between the lines, look for change from one data point to the next. You know, where do the big jumps happen? Do those jumps happen across each of the lines? So note, for example, that the total expenditures has kind of a steeper jump right here and right here. One of the things you want to look for is that borne out across the other lines? In this case, I would say it's mostly true, but this jump was more due to the private expenditures, whereas this jump was more due to the public expenditures. So little things like that can make a difference. And really, you know, obviously it takes a lot longer for me to do it when I'm talking it out, pointing at what I'm doing, drawing little things all over the graph. In real life, when you're doing this on your test, it's not going to take very long at all, because you'll just notice those things right away. And so notice that these things. Now, if you had noticed, for example, that it was always the private expenditures that were driving, you know, steep changes in the total, then that would be a thing to know moving into the questions. So. Yeah, change from one data point to the next, whether the slope is positive or negative, these are all going to be, well, I guess maybe right here there's a negative slope because of this right here. So there's a few places there, and maybe, hard to say about that guy. Anyway, but for the most part, the slopes are positive, whereas the greatest change, that's probably this section right here. And again, you know, making sure that you've tracked your axes correctly, making sure that you're keeping your colors straight. Note that they're not necessarily listed in the order that they appear on the graph. The top one is the total on the graph, where it's the bottom one on the key. So don't just associate, you know, where it is. Visually, you also have to look at color or pattern or whatever designation they're using for differentiating the lines on the line graph. All right, finally, tables, which are kind of the least artistic of the data interpretation things. So again, rows and columns. One of the reasons why they're more challenging, of course, is that they don't represent relationships between things as visually. So, you know, this could have been 5 pie charts, you know, with Australia, Argentina, Brazil, South Africa, and Japan, with the relative percentages of these things that they dig out of the ground as their percent of their average GDP from minerals and mining. So, that would be great, but it would take up a lot more space. So sometimes the table is the more space-effective way of doing things, but it can be more challenging. So because it's harder to spot the anomalies, harder to spot the things that really stand out. Clearly, Australia jumps out on gold. You want to kind of just scan quickly for things that are kind of unexpected. Brazil is the leader in iron ore. Bauxite in Japan is way out of proportion to all the other things. So you'll notice a few of those things, and then notice that this is, these are simply in alphabetical. Oh, they're in alphabetical order. No, they're not. South Africa does not come before J, and the GDPs are not in any order either. So looking for what other sort of sorting might have been going on. So note the big differences, any trends. This one doesn't really have trends over time. The trend that you might notice is that most countries have gold as their leading percentage, Japan being an exception and Brazil being an exception. What scale are things measured on? Billions of dollars, and then these are just percents. Percents are always out of 100. That's what the little sign means. And again, the title, if you have one. So, like I said, tables, especially because of the way that these go, will often be in conjunction with other types of graphs. So, the actual graphy graphs. So, just I guess don't assume that they're any easier than the other things because there's nothing visual to sort out. In a lot of ways, the lack of visual arrangement of information makes them more challenging.